When working to improve a system, it's important to know and know early whether the changes you're testing are leading to actual improvements. In this module, you'll learn how to use PDSA cycles to facilitate change and determine whether the changes you're making are having the intended impact. PDSA stands for Plan, Do, Study, Act. Think of it as a simplified scientific method that can be adapted to support systems transformation. As part of this module, we'll be discussing what a PDSA cycle is, how it works, and why it's so effective. We'll talk about the importance of including the wider community voice, the people impacted by the system, when identifying which changes to test. And we'll explain how small tests allow teams to innovate and contextualize change, and how you can leverage testing many changes to transform your system. Anytime you seek to improve a system, change will be required. How do you avoid implementing solutions that are ineffective or worse, that perpetuate the problem? Enter the practice of testing changes. PDSA cycles allow you to learn by doing, to test any change to see if it works as intended in your context, so you can set aside the ideas that don't work and optimize the ones that do. A key tenet of testing changes is that you start small to learn big. You leverage evidence, best practices, and your team's ideas and test them to identify the changes that result in sustainable improvement. In fact, the more transformational the change, the more important it is to test and learn on a small scale. You start with an initial cycle, one idea, one person, one day. We call it the power of one. When you test on a small scale, it creates a huge opportunity to learn about your change. Small tests minimize the chance of implementing a change that either isn't effective or, worse, causes negative outcomes. But that's just the start. Over time, you plan larger tests of change, incorporating what you learn along the way. This iterative process reveals what types of supports your changes require, so that by the time you make a change permanent, you can feel confident that it will be successful. Let's apply this to an example. Imagine you are on the leadership team of an organization that does a weekly check-in of staff morale. You've struggled with morale for some time and invested in a major intervention to improve it, a voucher for all staff to cover daycare costs. Unfortunately, after the change was implemented, you find that not only did it not improve morale, but it actually got worse. Very few people on the team have childcare needs, and this gesture felt quite inequitable. This is a classic example of a well-intended solution that created a negative outcome. By not designing an inclusive process or testing the solution, you've wasted resources, eroded trust, and missed out on a major learning opportunity. Testing changes is critical to improvement science for a variety of reasons. It allows teams to try out an idea in their context without having to commit to implementation. It helps teams to generate learning quickly and challenge assumptions about what will or won't lead to improvement. It builds a culture of learning and reduces fear of failure. And it provides more information about which changes to prioritize. Let's go back to our example. Having seen the response to their initial attempt to improve staff morale, the leadership team of your organization wisely bring the staff together to create an improvement team that's representative of the broader staff with an aim of improving morale. The meeting confirms that work-life balance is critical to morale, and that the two factors that feel high leverage for improving it are manageable workloads and flexible hours. They decide to focus on the general concept of flexible hours, and two team members take the lead using PDSA cycles to learn what works best. The first step in the PDSA is to create a plan. The plan requires that you identify what you hope to learn, articulate your predictions, and identify what data are needed to learn from your test. You will also note the specifics of your planned test, the who, what, when, and where. The team decides to test a condensed 4-day work week. Because there's some resistance to this idea, you choose to test it on a very small scale. One team member, Naomi, will run the test of change with her supervisor. Take a moment to review their plan. The next step in the PDSA cycle is to do the test. During the next week, Naomi works a 4-day week, and she and her supervisor take note of what worked as expected and what didn't. This is the study step of the PDSA. She notes that 70% of her planned activities were completed. Her supervisor gave her a 5 out of 5 for responsiveness, and they noted that high score was likely due to the fact that they had planned for the week in a way that prevented last-minute requests late in the week. She learned that other aspects of her daily routine were similarly inefficient and unplanned, and that increasing efficiency and planning could help her to complete more of her task list. She also noted that she was feeling excited about the challenge of completing her work over the 4-day stretch. Despite her initial skepticism, Naomi's supervisor agrees that things went well, and they identified some insights about what a 4-day work week could look like. This leads us to the act phase, a time to reflect on the results and decide on what action to take. Adopt the change, adapt the change, or abandon the change. In our 4-day work week example, Naomi and her supervisor decided to adapt the change and do another round of testing with the broader team, testing small adaptations to increase efficiency for everyone. Typically, you should think of PDSA cycles as expanding from a single small test into a ramp of subsequently larger tests, with learning along the way. PDSA ramps allow you to test big ideas on a small and increasing scale, learning over longer periods of time, under different conditions, with different people, in different contexts. This sequential testing allows you to figure out along the way what scaffolding will be needed to implement the change across the system. The idea is to fail-proof the change before making it permanent. Beginning with the power of one and rapid cycles of learning ensures that you're using resources wisely. This methodical approach limits the negative impact of any change idea that doesn't test well. In a real-world example, your team's testing model will look more like this pyramid with multiple testing cycles, moving from small to large scale as you work towards your aim. For those changes that work, your team will need to move from testing to implementation, where you build the necessary supports to ensure that the change is sustained. In summary, and to answer the question that often comes up, why go through the testing process when you could just make a change? You do it for the following reasons. To minimize costs and risks of strategies that don't work, especially financial and human resources. To challenge assumptions about what will make an improvement and what won't. To adapt something that worked elsewhere to your context. To build ownership of the change and reduce resistance. And to learn what scaffolding and supports will be required to make the change permanent and successful. For more information about PDSA cycles or to download templates of the tools we use, visit the Shift website.